My name is Ricardo Menendez.
And I'm Matt Carter. And we're going to be talking about our robot,
The robot
its components, their functions,
our team design
and
is
estimated cost.
basically a box-shaped device consisting of
The image
power
processing
supply,
starts with the mounted camera,
some
which takes an image
image
for the computer to
processing
interpret in real
software, and
time
some
using
control
software. The camera is provided for us, but the image processing algorithms are not. The use of the camera in MATLAB code will show which cups have balls in them and which do not. Based on this information, the robot will adjust its angular position to shoot the ping pong ball into the correct. The robot consists of 5 basic components: the main body, the power supply, the hopper, the camera, and the support for the bottom of the robot. The main body consists of a pipe and 2 servo motors. The hopper consists of a tube which the balls will go into and 2 gates controlled by 1 servo motor. The bottom support consists of a platform, a swivel, and a servo motor which itself has an amplifier for control. There is also a power supply which will have to be bought and a camera which is provided. This is a general overview of the robot structure. The structure is composed of 3 main components: the hopper, housing box, and the bottom support. The robot is safe and very portable. 2 of the 4 servo motors are housed inside the main body of the robot, and another is located under the swiveling base. Everything is screwed together, so when moving the robot, one does not have to unbolt or unscrew anything. Just pick it up and go. The robot's main objective is to launch a ping pong ball into a desired cup based on the image provided from the camera placed above the cups. Once the image is received, the robot's bottom support will move to a pre-calculated position with the use of a servo motor. While this is happening, 2 more servo motors will be continuously turning 2 wheels that will help with the velocity of the ping pong ball. The speed at which the motors turn the wheels is based on which cup is the desired target. The base is used to compensate for the angles of the 9 cups. The main body will be made to house the main components of the robot and hold them together. The main body of the robot will consist of a basic plexiglass box which will house a pipe for the ball's path and 2 servo motors that will be the driving force behind the ping pong balls. The body will also support the hopper, which is connected to the main shaft. The hopper is composed of 2 PVC pipes and a 45-degree elbow joint. The elbow joint allows for the angular trajectory needed to achieve the parabolic flight path of the ball into the cups. The cups were measured to be 6 inches tall and roughly 3 inches in diameter. Measurements and angles of these trajectories have not been calculated due to our robot not being fully constructed. A servo motor, gear, and gates are used to ensure that only one ball is shot at a time. The servo motor has a gear connected to it that operates 2 sliding gates, but the gates move in opposite directions because they are connected to 2 different sides of the gear. As shown in the figure above, if the bottom gate is in the closed position, then the top gate is in the open position. The gap in between the gates will be slightly larger than the diameter of the ping pong ball, so that when the bottom gate is closed, the top gate could be slid in and only one ball would be ready to shoot. When the command to turn the gear in the clockwise position is given to the servo motor, the top gate will close while the bottom gate is open. Once the bottom gate is completely open, the ball will go down the firing gate. The bottom piece of the robot is for support. The bottom support consists of a platform made of plexiglass. It has a ball bearing swivel which will be controlled by a servo motor bolted to it. This is so that the horizontal angle of the robot can be controlled so that the ping pong balls can be aimed more accurately. The main body of the robot, which has already been discussed, will be bolted down to the ball bearing swivel, like the video clip shows. Our estimated costs are $119, which is well below the $300 limit. The estimated cost may increase depending on where we get the rest of our components. Thank you for watching our presentation. We hope these details have given you more insight into our design, its components, and its functions.